Hello, welcome to my Physics 2212 Lab 4 Circuits. The purpose of this lab first is to understand the efforts of resistors in series and parallel. Second, use modeling to understand the behavior of capacitors and resistors. And the result I got is, first, current in RC circuit is time dependent. Second, the node and loop rules hold true. Next, we have the fundamental principles. First, node rule. Current flow into a node must be equal to the current flow out of it, result of changing conservation. Second, loop rule. The sum of all electric potential difference around the loop is zero, result of energy conservation. Third, Ohm's law. Current through a conductor between 2 points is directly proportional to the voltage across the points. Next, we have some assumptions. First, the circuit is the system and the surroundings are everything else. Second, resistance of wire is negligible. And last, the resistance of ammeter is negligible. Then is the readings of the first scenario, closed circuit. The predicted current is 0.0204 amps. The actual current is 0.02 amps. Even if we reverse the ammeter, the current is still the same, 0.02 amps. Now we have the readings of the open circuit scenario for predicted voltage. Delta V battery is equal to 3 volts. Current is equal to 0 amps. No current or potential difference or cross opening. Potential difference comes from batteries. Now we have the closed current and delta V across different segments. Delta V is equal to 0, which follows the loop rule. Current is equal to 0.0 amps. Ammeter reading doesn't change from the orange closed circuit because voltmeter has a high resistance, therefore current doesn't flow through it. The delta V is changing is showing the right bottom graph. Now we have the closed current amps in parallel to 100 ohms of resistor. Ammeter reading is 0.06 amps. Ammeter has very low resistors, so current will go through it instead of 100 ohms resistor. The calculation and results of resistance of 70 ohms, a resistor of 100 ohms, resistor of the wires and the resistor of ammeters are shown in the graph, which is 48 ohms and 102 ohms, 0 ohms and 0 ohms. Next, we have the RC circuit. For charging, 10 ohms needs 9.9 seconds. 20 ohms need 19.3 seconds. For discharging, 10 ohms needs 12.8 seconds. 20 ohms need 24.7 seconds. Then we have more RC circuits. A 9-volt battery, 200 mF capacitor, and 30 ohm bubble are connected in series. What is the RC value? The predicted RC value is 6, but the experimental RC is 6.88, which is very closer. And the data with the calculation are shown in the graph. Now we have the errors. First, human error in stopping the stopwatch and capacitor from discharging at the same time. Second, the reading of voltmeter and ammeter are not accurate. Last but not least, we have some discussions. First, what if we use the actual ammeter? The actual ammeter will have resistance and limit the total current. Second, what if we use the actual battery and no resistor? With no resistor, our model will predict the capacitor to charge instantaneously. However, actual batteries have internal resistance.